Hello, welcome back. We're helping you get ready for the SAT math portion, and the last time we left off, you were going to try this problem on your own and find out what the correct answer was. So now let's take a look at this one together. The front of a roller coaster car is at the bottom of a hill and is 15 feet above the ground. If the front of the roller coaster car rises at a constant rate of 8 feet per second, which of the following equation gives the height, h, and feet of the front of the roller coaster car as seconds after it starts up the hill? There's a lot going on here. So knowing that you can write in your booklet, like honestly for me, it helped to kind of draw a picture of this. So we're at some sort of hill. The roller coaster is at the bottom of a hill. The car. And the front of the car, right here, is 15 feet above the ground. Okay, so here's the ground. And we've got 15 feet here. And then it's about to start going back up, and it goes back up at 8 feet per second. And they want us to find out what linear equation here, or what equation here is the right one. So 15 feet above the ground is important. It's rising at 8 feet per second. And we've got some variables, h, the height, and time. Okay, so this I can already start to see this is a linear equation where we have some sort of initial at the very beginning with, no seconds. We're 15 feet above the ground. Sometimes it also helps me to draw a table. S seconds, height of the car at 0, it's 15. What would it be 1 second later? Let's see, it's climbing at 8 feet per second, so that would be 23. At 2 seconds, it would be like 31. So already I'm starting to see how things are kind of, how that front of the car is kind of gaining in height. So the height of the car is going to be, well, it starts off at 15, and then every second it gains 8 feet. So the height of the front of the roller coaster, I know that the height begins at 15 feet. And then it's going to grow in a certain way. And they tell me it grows 8 feet every second. This is another huge clue that we're dealing with a linear function. When you're growing by a constant rate, that 8 feet every second, you can count on it. It's not growing like 8 feet 1 second and 16 feet the next second, or 100 feet the next second. It's growing at a constant rate. You're dealing with a linear equation. And the more of these we see, the more you'll recognize that they can often be written as a way that you start and then a way that you grow, this constant rate of growth. And so let's look over here. Let's see, is it A or D? We're growing at 8 feet every second. The fact that the 8s comes first doesn't matter because 15 plus 8s is the same as 8s plus 15. So the answer is definitely A here. Before we go on to the next problem, I just want to show you something from the College Board, which is, they're the people that put on the SAT. This is the schedule for when you go sit down to take your SAT. You're first going to do your reading and writing, which is about 100 minutes, the first 100 minutes. The whole test is only 180 minutes. So you'll do your reading and writing, you'll get like a break or two in there, and then you'll take your math portion. And like we've talked about before, the no calculated part first and then the calculated part. And it's split up into 2 sections, 25 minutes and 55 minutes. And this gives you a good idea of about how much time you have for each question. No pressure, but some of these questions are not going to take you this long. And some will take you, a couple minutes to do. They progressively get a little bit harder as you go through the exam. But it definitely always helps your mindset to kind of have a clear idea of what you're in for. The essay portion is optional. Some people take it. Some colleges require it. Not a lot of colleges don't require it. So that part is totally optional. You could take the reading and writing and the math part and then just go home after that. And in these videos, we're working out problems in a real strategic way. We know that almost half of all the math questions come from these 3 topics, even though there's generally about 12 topics total. And so we're really honing in the beginning here on the most prevalent topics and starting with linear equations. Okay, here's our next problem. It's still in the no calculator section, and it is another example of linear equations. The equation above gives the amount C in dollars an electrician charges for a job that takes H hours. Miss Sanchez and Mr. Rowland each hired this electrician. The electrician worked 2 hours longer on Miss Sanchez's job than on Mr. Rowland's job. how much more did the electrician charge Miss Sanchez than Mr. Rowland? Okay, so I know that this is an important thing to remember, and the electrician worked 2 hours longer for Miss Sanchez. So she's going to pay a little bit more than Mr. Rowland, and we want to know how much more did she have to pay. Well, Mr. Rowland's cost is going to be C equals 75H plus 125. But let's say that the number of hours that the electrician worked for Mr. Rowland, we're going to call that R. So those are how many hours he worked for Mr. Rowland. And then Miss Sanchez, we really don't know the number of hours he worked for either of them. We just know that for Miss Sanchez it was 2 more hours. So Miss Sanchez is the electrician is going to work not R hours, that's how many he worked for Mr. Rowland, but here the electrician is going to work, what do you think it is, R minus 2 or R plus 2? So this is Miss Sanchez, and he's working longer for her, so it's going to be R plus 2. The number of hours he worked for Mr. Rowland plus 2 more. And then we can't forget there's still this plus 125. So this is kind of the key to the problem, to realize that the cost for Miss Sanchez is 75 times the number of hours he worked for Mr. Rowland plus 2 more, plus 125. Once we know that, we can kind of clean this up. So Miss Sanchez, let's just put a bar under here so we know that these are separate. That's not a very good bar. These are separate equations, separate ideas. Okay, so 75 times, and we're going to go ahead and distribute this 75 through the parentheses and multiply it by both of those. 75 times R plus 75 times 2 is 150 plus 125. I can already start to see that he worked, this is the cost for Mr. Rowland, and the cost for Miss Sanchez is almost identical, but you've got an extra $150 in there. So automatically I can see that this is, she's going to pay $150 more. So we see that Miss Sanchez pays this $150 more. Another way of thinking about it is, as soon as you notice that this is a linear equation, you know that every hour things are going up by $75. The cost is going up by $75. So almost automatically, you know, it's fine. It's good to work through all of this too. But if you're in a time crunch, you could say, oh, okay, I recognize that every hour things are going up $75. So if he's working 2 hours longer for her, then the cost is going to go up $150. So Mr. Rowland's cost was this, and when we got to Miss Sanchez's cost, we noticed that this was the same. These were both in Mr. Rowland's cost. This was the only extra piece here. Okay, here's our next question. We have this big honkin' long equation. In the equation above, A is a constant. Okay, so that just means it's a number. If no value of X satisfies the equation, what is the value of A? So this is kind of a tricky question because they're not asking you to, solve for X, which would be a little bit easier, but they're saying, there's this weird condition where if A is a certain number, there's going to be no solution to this equation. So what would A have to be? So on a problem like this, my first instinct is I want to try to clean this up. I know there's some X terms, and I know that there's some constants. So maybe if I try to get all the X terms over on one side and all the constants over on another side, I can kind of start making sense of the question that they're asking. And so that's what I'm going to start doing. I don't know what A is, but it's not a variable, it's a constant. The only variable in this problem is X, and it looks like there will never be any higher powers than 1 on X, so it is a linear equation. And I'm going to work towards trying to solve that linear equation. On any of these videos, it's a good idea, you can pause the video right here and try to work it out from this point on your own. You'll definitely learn better that way if you're taking some steps to attempt the problem before just watching me do it. So go ahead and pause the video and try to solve this equation and see what happens. Okay, when I go to solve this equation, first thing I'm going to do is get rid of a lot of these parentheses by just distributing through, so just multiplying through each of those. So we'll stick with 2x minus 15 here, and then we get 3x plus 3 times 5 is 15, plus 5 times x, and then 5 times negative 1 is minus 5. I'm going to go ahead and collect all the terms that have an x in it over to the left side, and then try to get all the constant terms over on the right side. So as long as I do the same thing to the left and the right, I can do it in an equation like this. And so I've got 2ax minus 15 on the left, and I'm going to subtract 3x and subtract 5x. And then on the right side, 3x minus 3x goes to 0, 5x minus 5x goes to 0. So on the right side, I only am left with 15 minus 5, and that's 10. So all of that equals 10. And let's go ahead and add 15 to both sides to get this constant term over there. And we'll be left with 2ax minus 3x minus 5x equals 25. So each of these terms has an x in it. And so here's what I'm going to do. Well, I know that minus 3x and minus 5x is going to be minus 8x. And then on the left side, I can actually factor an x out. And I have 2a minus 8 equals 25. And then we're going to divide both sides. Try to get x all by itself by this guy. And this is where I start to see, these guys will cancel, what the heck they're talking about when they ask the question that they ask. So I've solved for x here. And you can probably see it too, that if a, first of all, if this denominator is 0, that's a huge problem. You can never have 0 in the denominator of a fraction. It doesn't make mathematical sense. So we need to make sure that 2a minus 8 is never 0. So from doing all this work to solve for x, I have come up with the fact that 2a minus 8 can never be 0. And so we're going to find out where that might happen, because that's going to be the value of a that causes the problem that there is no x that satisfies the equation. So if 2a minus 8 does equal 0, that would be 2a equals 8, divide by 2 both sides, and that would mean that a equals 4. So when a equals 4, this is a major red flag, major problem. We do not want a to be 4, because if a is 4, that means 2 times 4 minus 8. This causes a 0 down here, which would mean no solution for x. So this guy's the answer right here. We definitely don't want a to be 4. It causes a problem where there's no solution for x. Okay, here's the next problem, and I want you to take a stab at it. So you taking a stab at this problem on your own first will better prepare you for the SAT for sure. And then we'll work it out together in the next video. But take a minute, pause this video, and work out this problem and decide A, B, C, or D.